Welcome to Mr. V Teaching Math. In this session, we're looking at equivalent fractions. Well, we're going to look at pie again. I happen to like pie a lot. As I mentioned before, I'm eating pumpkin pie. And in that previous example that I had used, I had gone and eaten 1/4 of this delicious pumpkin pie. Now, I just so happen to really like my mom's pumpkin pie more than anybody else's. But there's no way that my mom will ever cut a pie into quarters. Those are too big. And despite my dad's complaints that eighths are too small, this is how my mom cuts her pumpkin pie. She'll cut it into 8 pieces. Now, I'm smart enough and I know math well enough that I can still eat my 1/4 of a pie. You see, I just eat 2 slices. And you're going to notice that I'm still going to eat exactly the same amount of pie. This is what we call an equivalent fraction. In this case, I ate 1 out of 4 pieces. In this case, I ate 2 out of 8 pieces. However, these are equal to each other. I still ate the same amount of pie. They're just described differently. The pie got cut into 8 pieces and I ate 2 of them. The pie got cut into 4 pieces and I ate 1 of them. Notice this, however, I can easily convert this fraction into this fraction if I simply multiply this by the same number. 1 times 2 is 2, 4 times 2 is 8. That's important. And these have to be the same. I can't just throw in 2 different numbers there. It won't work. Okay? So this is the basic concept of what equivalent fractions are. They're the same fraction described differently. 4 pieces, I ate 1. 8 pieces, but all the pieces are actually smaller, so I ate 2 of them to equal the same amount. All right? Now, the kinds of questions that you're going to be asked to solve in the assignment that follows this, in my classroom at least, is I'm going to ask you to draw some diagrams. For instance, these are equivalent fractions. We have 1/3 and 3/9. These happen to be equivalent, and I'm going to be asking you to draw some diagrams. Now, you could draw diagrams using circles, and that would work just fine. So you can do it this way if you want. You could also draw them this way. So first of all, I have to take my, well, you can make this a chocolate bar if you like chocolate, or whatever you feel like making it. It's a bar that I'm going to cut into, how many pieces? It's going to be cut into 3 pieces. Cut into 3 equal pieces. Now, how many of those pieces are the pieces being consumed? Well, 1 piece is being consumed. If it's a chocolate bar. Or whatever. Now, in this case, I have to break it up into 9 pieces. Now, I want these pieces to be quite a bit similar to those ones above. You can already see that I've got essentially the same thing, but now I'm going to cut it up into 9 pieces by breaking those up a little bit more. 9 pieces, and how many have been consumed? Well, 3 of them. Again, you can see that these are equivalent fractions, even though this is cut into thirds and this is cut into ninths. The same amount is consumed. All right, so that's how to deal with that. Now, what if I'm given this kind of question and they want me to create an equivalent fraction, but they give me a specific number to work with, and they say something like this. Take 1/4 times it by 4. I'm going to create an equivalent fraction. 1 times 4 is 4. 4 times 4 is 16. 4 sixteenths is the same as 1/4. That's how you do that kind of thing. Now, what if I'm given this and they want me to find a whole bunch of equivalent fractions, whether I have to find them in a group or whether I have to create a whole bunch? I can simply take this and start multiplying by a whole bunch of numbers. I'm going to start with 2. So I'm going to multiply this by 2. 2 times 2 is 4. 3 times 2 is 6. There's an equivalent fraction. 2 times 3, that's going to give me 6. 3 times 3 is 9. There's another equivalent fraction. Let me multiply by 4. 2 times 4 is 8. And 3 times 4 is 12. And I could go on and create a whole series of equivalent fractions. And that's going to be useful in some of the work you're going to need to do. But what if I'm given this kind of question? I have 1/3, and I want to put it into sixths. How many pieces will I have? Well, now you need to think. What do I multiply 3 by? What do I multiply by 3 to get 6? And I have to put the same number up here. Well, 3 times 2, that equals 6. Therefore, this has to be 2. 1 times 2 is 2. And that's how I solve that type of question. Now, what if I'm given this kind of question? This question gives me a whole bunch of fractions, and one of these fractions is not equivalent. So I'm going to test them all. Go figure out which one does not belong. Which of these is not like the other? So if I take a look, I'm just going to look at 2 for now, and I'm picking 2 at random, the first 2 actually, and I'm going to go 2 times what equals 5? Ooh, 2.5. Well, that's possible. I could actually multiply this times 2.5. But if I do 1 times 2.5, that should be 2.5. These two are not equivalent. Okay, well, I've got a good start. Those two are not equivalent. I have to look at the other patterns. I'm going to take the 1/2, and I'm going to compare it to the 2/10. To turn 2 into 10, I have to multiply it times 5. So 2 times 5 is 10. So I should multiply the top by 5. 1 times 5 would be 5. That's not equivalent. It's giving me a big hint which one is probably not going to belong. Let's try this one. Can I turn 1/5 into 2/10? Well, 5 times 2 is 10. 1 times 2 is 2. Well, that's good. So those two match. 1 times 3 is 3. 5 times 3 is 15. Those match. 1 times 4 is 4. 5 times 4 is 20. Those match. Therefore, this one does not belong. And those are the kind of questions you're going to be working with when you're dealing with equivalent fractions.